Today, we're diving into a critical cybersecurity topic: privilege escalation via Docker socket abuse, a vulnerability that every security professional, developer, and system administrator should understand. The Docker socket, typically found at /var/run/docker.sock, is the primary communication channel between your Docker client and the Docker daemon. This Unix domain socket acts as an API endpoint, allowing local processes to manage containers, images, and networks, and it runs with root privileges, making it a highly sensitive resource. One of the most common abuse scenarios involves mounting the Docker socket inside a container, granting that container direct control over the Docker API. If untrusted code runs within such a container, it can compromise the host machine, leading to significant security breaches. Attackers can exploit this access for privilege escalation, creating new containers with the host's root file system mounted, effectively gaining root access to the entire host. This allows them to read sensitive data, install malware, or create new user accounts with elevated privileges. Exposing the Docker daemon over a TCP port without TLS encryption is another critical vulnerability, as it grants remote attackers root access to the Docker host. Misconfigurations, such as running containers with the privileged flag or broad capabilities, further exacerbate these risks, making systems easier to compromise. The most effective mitigation is to never mount the Docker socket inside containers unless absolutely necessary. If Docker in Docker functionality is required, isolate it using rootless Docker, gvisor, or Kata containers for enhanced security. Always use TLS encryption for secure communication if remote access to the Docker daemon is unavoidable. Implement the principle of least privilege by avoiding the privileged flag and dropping unnecessary Linux capabilities. Regular security audits are crucial to ensure containers do not have excessive privileges or access to sensitive resources. Keep Docker and the host operating system updated to patch known vulnerabilities, enabling automatic security updates where possible. Consider using a Docker socket proxy to limit the commands that can be executed through the socket, adding an extra layer of defense. Regularly scan Docker images for vulnerabilities using tools like Trivy, SNYK, or Docker Scan, integrating these into your CI/CD pipelines. Finally, implement network segmentation and use firewalls to restrict traffic between containers, limiting the blast radius of any compromise. In a real-world scenario, a compromised web application in a container with a mounted Docker socket can lead to container escape. The attacker can then use CRUT to gain root access to the host, exfiltrate sensitive data, and move laterally to compromise other systems. By understanding these risks and implementing robust mitigation strategies, security professionals, developers, and system administrators can significantly protect their containerized environments. Stay vigilant, secure your Docker sockets, and safeguard your systems against privilege escalation threats.